Okay, guys, thank you so much for joining us. It's another day. Today, today is the third day, and in the second week of our Precision Agriculture Incubation Program. I'm actually delighted to actually have every one of you join us. So tell your friends, share the group. Share the link to this section either on YouTube or LinkedIn. Join us. It's going to be an interesting class. So today we have an amazing and practitioner in the field of agriculture, leveraging on IoT and embedded systems, applications in agriculture, and that's the person of Matthews Ajibola. But before then, I want to actually invite Joseph to quickly give us a brief about our organizer, that's Precision Seed Academy, as quick as possible so that we can actually cut to the chase today with Matthews. So over to you.
All right. Thank you very much, sir. Uh, Good morning, everyone. It's really good to be here again, and I'm glad we are progressing. So this morning we are starting on embedded systems, but before we go into the full program, so I quickly want to give a quick recap of what Field Academy is all about. So Precision Field Academy at Precision Academy, what's our vision? So our vision is to create a world where every young person, uh, regardless of their background, has the opportunity to become a digitally savvy farmer or agricultural professional, driving sustainable and equitable growth in their communities through the transformative power of technology. And our mission is to raise the next generation of farmers that are tech inclined and digitally savvy. So this is more like a driving force. We are so much concerned about every young person to be able to create an inclusive society that relates to digital technology and how we can transform the future of agri-food system in Africa and around the world. So about Precision Field Academy, we are a social enterprise. We build capacity of young professionals in modern and emerging technologies for the future of work and to lead with precision agriculture. Because there is a call that agriculture has to change, agriculture has to go digital, and uh, we have to change our way of practice, yes, from conventional and traditional method, leveraging digital technology for us to step productivity, efficiency, and precision in agriculture. So what's our methodology? Our methodology, we believe in three core methodology, which is education and knowledge sharing, training and skill development, coaching and mentorship. So part of education and knowledge sharing, this is what we are doing now in respect to the Precision Agriculture Incubation Program. It also includes the part of skill development because this program is divided into two phases, which is the virtual lectures and the on-site hands-on experience. So also we have coaching and mentorship, and this is what we do at Sean Field community. We'll provide insightful informations and expert-led mentorship for participants, yeah, to be able to find their balance with any issues they're having as regarding precision agriculture. So in lieu of this, we have other tech skills that we actually focus our gaze on, part of which is drone technology. So we are leveraging drone technology as a digital emerging technology to redefine the way we practice agriculture, which comes in terms of leveraging drones to fight pests, to manage pests, to also collect data, useful insightful data for farmers to farm efficiently. We also have geographical information system and remote sensing, the use of GIS, leveraging GIS to uh, collect data about farmland or certain places that we actually have interest on. It's also come in terms of research work and all other forms like that. So we're leveraging GIS and remote sensing basically. So also we have data science in agriculture. So this is more like the intricate part of the data, how it works, the algorithm, then how the front end and the back end of using data to optimize agriculture. Another skill we have is robotics and IoT, that's Internet of Things. And I'm glad we are actually, I mean, today's topic is centered on more on robotics, embedded system, and Internet of Things. We'll be able to see the viabilities of this technology and how it can be leveraged to optimize precision agriculture. So also we have artificial intelligence, AI, and machine learning. Putting artificial intelligence together, this is more like leveraging on digital train models for us to see results in terms of precision agriculture. Uh, and lastly, we have the enterprise development. So enterprise development, the goal of everything at Precision Field Academy boils down to you creating sustainable solution avenues, that is turning your passion into profitable enterprise that can actually render solution, provide insightful information, yeah, through services that can help agriculture grow better. So why do we do what we do? And this is our motivation. So our motivation is we discover there is a skill gap that really needs to be closed, and young professionals need to build skills, both in the technical part and the enterprise skills for the future of agriculture. So another part is we observe that like observing the trend is not enough. I mean, globally, new technologies are springing up, and we are here putting our hands, observing. Okay, wow, we are like we shouldn't just be wow that these new technologies are coming up. Our youth need to be involved. They need to be an enabler and player in these emerging technologies. We are now looking to designing our own technologies that is going to transform the fourth industrial revolution. So also we have another point here is technology is key to unlock African agriculture potential. So for African agriculture to thrive effortlessly, we must leverage technology 100%. So why you should join us as an individual? I think the reason why you should join us are listed here. So we are creating the future we want in agriculture. That is, we are changing the narrative. We are bringing up a new technologies on board, new initiatives on board to actually see that agriculture game is totally redefined and is being practiced effortlessly. So we also connect you to information from which comes from the world of opportunities, such as in terms of scholarship opportunities. We can also get opportunity to hint, and that is from internship perspective and volunteership. You actually want to develop yourself, yes. So through aspect of volunteership, so this can actually uh, come in for you. So on both local and international scale for your career growth. So also we have skill development through project collaboration, community interaction, and workshop. So this can for the workshops. Comes in programs like this, community sensitization, and also collaboration with research institutions on how to develop digital technologies that is transforming agriculture. And lastly, we have access to coaching and mentorship from industry leaders and professionals. This can actually give you a guided approach on how to become efficiently, yeah, in your career path in precision agriculture. So at Precision Field Academy, we are building a community of young tech inclined and digitally savvy farmer and professionals. Thank you.
All right. Thank you so much, Joseph. Yeah, again, to reiterate, guys, all we are actually doing and making efforts to do is to actually build a community of tech-inclined and digitally savvy farmers and agricultural professionals who will not just be aware. Okay, it's good to be aware. We will not just be observers, but we will be leaders, we will be players, we will be influencers of the fourth agricultural revolution. So, without further ado, that is why we are actually bringing on board our guest speaker and facilitator today on the training on is going to be introducing us to the into the world of IoT and embedded systems in agriculture. But particularly, it's going to be talking about embedded systems design and application for agriculture 4.0. That's the fourth agricultural revolution. So join me as I welcome Matthew Ajibola. So Matthew Ajibola is actually the founder of Maotronics. So when I say he's a core practitioner, so he's obviously a core practitioner. So and I believe that you are actually count yourself lucky and privileged to actually be learning from him today. So he's a practitioner an entrepreneur when it comes to IT and embedded systems, providing various products for agriculture and also related fields. So he's a founder of Maotronics. So Matthews, you are most welcome, and you can actually put up your screen when you're actually ready for us. Thank you so much.
Thank you very much, Mr. Femi. Good to be here. It's a great privilege to be part of this incubation program, and I'm so happy to be able to share my little experience and to be able for us to learn from each other. And it's great for us to see how we African Nigeria we are revolutionizing agricultural sectors and as a young youth and giving our digital footprint into the world of digital agriculture. This morning I'll be sharing my little experience in embedded system design and application for agriculture 4.0. Great. The question is, what is embedded system design? When we look at embedded system design simply means interconnectivities of hardware and software together to perform specific functions. Today, we've seen how the medical line, automobiles has been revolutionized, and it's of great privilege for us to see that applications coming to play a major role in agricultural sectors. And that is the vision behind agriculture 4.0. If a medical doctor could perform operation with the use of robotic system, automations, or the use of electronics to be able to complement its physical ability to be able to carry out a particular task. We as an engineer can't see a farmer be able to do farming systems or do farming operation with the aid of electronics and computer application systems. That is why every professionals, every expertise, every single engineer coming together to say, okay, let's apply embedded system principle, embedded system design into agriculture by designing a smart solution system that can ease in agricultural practices and give easy food production for the community. And that's where embedded systems begin to play a major role in agriculture 4.0 in creating smarter ways of farming, controlling your robotics, your tractors, from applications of your drone systems and other aspects of electronics. Now, let's look what is embedded systems. Embedded system simply means that you are putting your computerized systems and hardware together to be able to perform a specific task. Now, what is those hardware that we're talking about? What are those computer hardware that we're talking about? We are talking about from your microelectronics, from your microelectronic components, from your resistors, to capacitors to transistors to your relay. Now, in the olden days, there's what they call logics. Logics is used to perform mini automations. That's back in 60s, whereby people want to, computer has been playing a major role in day-to-day life, because when you talk about computing just means we are representing gods. We are creating a replicate of the way God made human, because we are the first computer system, we human beings. Because for your brain to connect with other parts of your body to perform specific function, for I to be able to talk, for I to be able to raise my hands, for I to be able to do specific function, this is the functions of God-made computers. Now, we as a God-made computer, now we start creating God-made human electronic computer that can perform some function that our supreme God, our supreme being, has made us to be able to perform, and that is why embedded systems come to place. When you think about embedded systems, as long as you have electronics in your house, in your environment that has a digital display or a digital footprint, is simply embedded system applications. From your microwave to your fridge, to your iron, to your radios, to your TVs, these are embedded systems. Once they can communicate with either remote, with your RFID, your Bluetooth, your wireless signals to communicate, these are embedded system design. These are embedded system applications. So we begin to see this. If this has already played a major role in entertainment, in other things, how do we apply it to agriculture? Now, we need to understand the logic, the principle behind it, and to be able to come up with a design patterns. Now, imagine embedded system like a chef that want to cook, and you want to cook a particular delicacy. And the delicacy, let's take a simple sample of a food. Let's say we want to cook okra, which is our local food here. And you want to cook okra comprises of your pepper, the okra itself, you need other ingredients, maggi, salt, and you combine them together, give a case of what? Okra soup. You want to add a vegetable to it, you want to add all that, you want to have your crayfish, your meat. Once everything comes together, it becomes a soup that you can eat. Then the same thing in electronic design. In all these devices, engineers come together to combine resistors, capacitor with a particular relay IC to execute particular tasks. For example, I want to let my door to open by itself. What did I need? What are the components did I need to come together, and what are the power rating that I need to come to know? These are things that make up you designing a particular devices, and that is the art of embedded systems. We look at embedded system as different microprocessors. Embedded system has different microprocessors that combine, easing you to be able to design a particular task in agriculture and in agriculture, or to be able to carry out operations. Now, you understanding, gaining ground knowledge of this will be able to we allow you not to just do the application, but to understand the engineering aspect of it. Now, before we use discrete components to perform operation, then you see a gigantic system. For example, now if you look at the way our laptop has been revolutionized from having a bulky laptop system, now you have a very slim laptop system. It's because that the components has been transformed from discrete components to SMD components, which they are micros. And what happens is that we're reducing the use of more of discrete components and come to digitalize systems. And that's what embedded system is. Now, before there was a different use of relay IC, a good example of where you can see IC like this to be able to perform tasks. Now, PIC and ARM processor come into play, that you can write some computer code that eliminate the use of more components. Now the system now become compact, micro, then can perform other tasks that other components will do. And that is why embedded system is coming actively playing a major role. And what are these embedded systems? They are microprocessors. They are brains. They are brains. Brain is the heartbeat of every embedded system design. It's just like you have an empty brain. Now, the IC that has been designed for you to give them instructions, for you to be able to be creative about it. Once you understand one or two programming language, then you can create you can program the microprocessor to be able to do a specific task. Now, in application in agriculture, now we need to understand the kind of components, the kind of elements or tools that will be needed in be able to achieve agriculture 4.0. And other embedded system design, we have different vendors that already designed different microprocessors, different chips that can be programmed to be able to achieve to be able to come up with innovative solutions to carry out a specific task. So we have the life of PIC, which is programmable integrated circuit. We have the life of ARM processor, which are in our mobile phones, our computers. We have the life of Atmens, which is in our Arduino's board, and different kind of embedded chips. And these are one of the examples that I showed on my slide. Now, how do you apply these things? I've said it in my earlier speech. We have it in the medical, we have it in automobile. Now we are doing it in agriculture. When we look at Precision Academy, they are major in drones. Now they are doing applications of drone. But now, what are the heartbeat of what makes drone to work? That is where embedded system is playing a major role. What are those components? Resistor from the propeller, from your battery. How did they come together? From your image sensors and with the cameras. How are they interconnected to be able to do a specific task? The act of carrying out operations or making drone to work is where the microprocessors, and that is the embedded system. So that's the embedded system. We could see it from a slide. One of the example of the feed. These are our feed whereby we deploy one of our irrigation systems. This was designed in-house to be able to ease in the operations of the farmers, from carrying out interconnectivities of sensors to measure different water thresholds within the soil, and then send a command to the cloud. And then once the command is not meeting the requested preset data, then an operations or a task is being carried out. And these are where we are applying embedded system design in agriculture, in solving irrigation systems. And also, as we've seen it in Precision Academy, they are applying, they're using drone to solve particular problem, whether capturing the plant population. But the heartbeat of it is that a microprocessor is playing a major role to be able to work for cameras and other sensors to be able to capture data, and following a program instruction algorithm written by a specific engineer, drone can be active. And that is why we have drones, because an embedded system engineer design all the layouts and couple them together to be able to have what we have, a device called drone, to be able to perform a specific task. This is one of our feeds whereby we are using what we call penetrometer to be able to measure what is happening. We build, we can be able to know root and tubers, their yield, their structure, their weight, their length, what is happening down the road. Now, it's not, the computer is not seeing it as a root. Remember, the computer is seeing it as a signal. Now, programmatically, it's turned out to be able to read and interpret it to human's language. Now, you now see it as a word, as oh, the root is 11. The root is 1 kg. The root is the constitutional area is maybe about 1.5 diameters. So with the computer instruction that is written by our team, then translate back to human's language, which you can see on the screen, or you can see it on the server, that is, okay, this system is reading 10 root, 5 root, then can give instruction to the farmer, okay, go to your field and go and harvest, or go to your field and go and check, okay, your plants need nutrients because at 5 months, this is what you are getting. And the same thing also happens back to relating to this platform that joins us, which is Precision Academy. The drone is not seeing the image, whether a maize, cassava, soya beans, as soya beans. It's seeing it as a signal, 1 and 0. But programmatically, it's being translated back to an interpretable instruction for the human eyes to see through the use of specific programming language that is written into the microprocessor, into the microchips. Now, it cannot be interfaced with with the screen to be able to what human readable. Now we have these another applications of it, whereby we are picking signals or environmental signals, and we are sending it to the cloud to be able to monitor soya beans and other leguminous plants. These are the designs that was designed in-house in this IITA field, whereby we look at the climatic conditions of that environment, and it's being remotely sent into our cloud server to be able to make decisions. Now, what makes this system to be able to possible is that we pick up a microcontroller with our temperature sensor and other sensors. A good example, this is one of the sensors that the drone use, which is called the image sensors. That whether you are using your LDR, which is light for lighting sensors, and other relative sensors, which at the course of this training I'll be showing us, because I believe once we understand the applications of it, go into the engineering, learning the programming language, learning the schematic designs, how the engineer design layout, like the way architecture designs the layout of a house. The same thing also happens in the engineering world, in the embedded system world. All these devices that we are holding, from our laptop to our router that connected us together to the server system itself is designed systematically by the engineers, and this system has been interpreted by other architectural design engineers to be able to make it to be for what we are seeing as a device, and put it into a closure casing for individuals to be able to use for a specific task. One of our products that has already been designed, this is a product of the iWeb also. This is iWeb. Now, this device is to be able to auto switch. Imagine your tap in your house, you don't want to use your hand to switch it. Now, what this system does is to remotely, you can just click on the dashboard, on our dashboard, and activate it to be able to allow inlet of waters. And that's one of the things that is performing the smart irrigation system that we're doing. Now, this was another one of our feeds. This the green one was back then 10 years ago as an undergraduate student in UNAM. This was my final year project, whereby we're using a computational system. Back then, digital agriculture was T0, was not yet welcome fully in Nigeria, in Africa, because you were talking about you want to use computers to do farming, who is interested? But back then, we already have this vision, and also the founders of this platform, whereby we share a lot of vision together about, okay, this is a vision that I have for digital agriculture, that computer can take a major role. And we started this project back then 10 years ago, and this project has given back to 4 startups today. Now, On the other side there, this is one of the projects that we're handling with Cornell University in US, whereby we're using steam. We're creating a system that cooling the environment. And this system was designed here in Africa, here in Nigeria, to be able to monitor the flowering of cassava. So we're cooling the environment to reduce relative humidity to the maximum desired amount of condition that we want, and then put the sensor to activate the mister if the temperature is beyond maybe 30 degrees. And this system was designed in Nigeria, and that is applications of embedded system design in doing what? Climate, environmental control, temperature, relative humidity, and other climatic conditions. Now we also have this. You can see this is a dashboard. A software is written whereby it's communicating with the hardware and it's pulling data into the cloud. Now the question is that how is this magic possible? There's no magic behind it. You just understand the reading. And what are those readings? How did this IC communicate with your software? Now there's what is called, there are protocols that we need to understand. And is that we are using what they call HTTP, or an HTTP communicate with your processor using either you are using what they call ASME communication protocol, or you are using what they call I2C. I2C, these are architectural design inside these IC. There's always what we tell anyone. Once you pick any particular IC, it has what they call data sheet. Data sheet is to tell you, the user, how the maker of this microprocessor has designed the memory and other functions. So if the memory of each microprocessor has their own capacity that they can take, like also we have the human being, the baby has their own weight, a youth has their own weight, elderly person has their own, fat and thin, that's their minimum weight, and they have the individual human being has their capacity of stomach, of the kind of food that they can absorb. It's not by your weight or your height that will determine the amount of food that you can consume, but by amount of your potential energy that you have. And also the same thing is happening in the computer world. Every microprocessor has that bytes, the memory that they can contain. So is this memory that will determine the kind of instructions that you will take, that you write into the microprocessor using a particular programming language, which we still talk about. Now, this particular language cannot interface with this microprocessor with other components. This is a GSM module that has a SIM. Just what happened in the phone that you are holding. This is the major add bit of it. This is the component. Once you slot in your SIM. This is a SIM. This is an example of SIM card. Now you slot it here. You slot in. The SIM card is coming into the SIM card. Enter a particular angle here. Here. Now these modules as architecture, how you can be able to interface it with microcontroller. And the same thing is what happened in your phone. Your phone has a microcontroller that interfaces with your SIM slot. Now, your SIM slot has different protocols, communication protocol, where we have what they call RS1, RS2, and powering point, whereby you send your power and you go like that. So that way, is when you interface it with now microprocessor, you can use it to perform a signal, can receive a satellite communication, and then the satellite communication, you can write a particular computer algorithm to perform another functions. So this is another where we apply embedded systems for in-house farming. This is in IIC, whereby we created a climatic environment for tissue culture plants, and that is where we apply embedded system design. Now, this is another application of embedded system design in biogas. So we wanted to monitor the digesters, how they are carrying out different gases that they are bringing, and then this system was designed now using embedded system knowledge. we can see in-house unboxing a particular devices that was designed and how they are performing. These are an enclosure is open up for us to be able to see in the skies. Now, I don't know if you heard about what they call farm boats. Farm boats, I am farm boats founder in US started this movement 10 years ago, and farm boats has been used across the US academic institute to be able to do what they call CNC farming. CNC principle is what you use in your printer. When you see your mirror, a good example, you see your photocopy machine move up and down. Then the same principle was now used to cultivate vegetables or any other agricultural produce. Now that the machine can move from point to point, put in water into the soil or put seed into the soil to plant using particular planting space. So when we talk about generally, whenever you want to design your field as an agricultural expert, there's always a field layout and plant spacing. That plant spacing instruction now was programmatically giving instruction into a microprocessor to be able to carry out that task that human being will be able to perform. That was what be able to lend on to invention of what they call farm boat today in US, and that's the picture there. So as I've talked in my early slide that embedded system design has architectures. So we have applications, we have the middleware, we have the operating system and the device drivers. Now, whenever you open your laptop, you install any app, that is applications. What makes you to be able to install that applications on your laptop, on your phone, that's what they call middleware software. And that is where embedded system engineer comes to play. There are two kinds of application that is developed. So we have a software application and we have what they call a firmware. So a firmware is what runs underneath your microprocessor for it to be able to accommodate application software. So this is the architectural of embedded system design, and every single device that you are holding right now, these are the principle behind it. Once you understand this principle, you don't need to be, you can be a great expert and come and design what you need. I am a graduate of horticulture, and I'm speaking to you that I don't need to go and study elect or mechanical or this before I be able to do all these things. It's through the reading and understanding documentations of how all these things work that I was able to be able to start developing solutions in agricultural sector, which is under agricultural 4.0. Embedded system design, this is the sequential way how they come to be. I make an example of you want to cook, and the same thing also happens in every single devices that you are holding today. Before you see them, they don't just design it and you put battery and it works. So microprocessor has its own limited signal powers. So the first thing to do whenever you want to design any devices or you want to invent any solution that is technological inclined, you must have your power supply, you must have your microcontroller, and you have the memory, we have the timer. Now, where I was talking about how your devices send signal either to your phone, to your class, that is what we call communication ports. And on that communication port, we have different protocols that we must understand it. We must understand. If you have another session, it could be pure practical, whereby we design maybe temperature sensor. You see how we make all these protocols that we talk about here today, and we apply it into actions in designing a particular solutions that we can see it working in agriculture. Whether you want to measure your soil threshold, you want to do a smart greenhouse, we can do it and you can do it. You don't need to. We need to understand is the principle. Or even though you can give any engineer your idea, but once you understand how to interpret your idea with the understanding of embedded system principle, you can send your idea to any expertise to be able to carry it out. But understanding what you want to do is what really matters to become an inventor. Example of this embedded system design modules that we can use, we have Arduino. Arduino is commonly now for educational purpose, like this kind of academy where we are now. If you are coming into that platform to design any robotic system, the Arduino is a first welcome module that you'll be introduced to be able to start using. Then when you are coming to advanced level, you start talking about microcontroller and other ATMES processors, like something like this, like something like this on this side here, at the side there. These are ATMES, these are ARM processors. So they are more of SMD, that is onboard processors, which involve a lot of technical expertise or technical know-how. On this board alone, this is what they call Vero board. Vero board is where you put your components and test run it as an idea before you see it on a permanent board. On all those green board that you are seeing on your electronics, they are called PCB board, printed circuit board. This is an example of one of our devices, but these are educational, these are intelligent bell that was designed maybe about 15 years ago. We can still see it now. So like that. One of the devices that was designed, this for steam. So we have this. This is used to carry out the back research to monitor environment for cassava. Was designed back then with Cornell University. Now, another devices that we implement in agriculture is this another devices component of iWorks. This is for flow rate. You want to measure amount of water that is flowing through a particular channel. So you put this sensor and then you interpret it with microcontroller, and it will give you that signal. You will be able to see amount of how the water is flowing, the frequencies of that, the current of that water, and then you can interpret it to do any particular actions. Now, for us to be able to do all these actions as a novice, what are the technical know-how that we need to understand? First of all, there is a particular programming language that we must understand, and this is C or C++. When you want to come to program microprocessor, you must understand microprocessor has its own language. Just as we are communicating with English, English is a language that if I want universal platform to be able to understand me, I won't communicate in my local dialect, which is either Yoruba, Igbo, Hausa, or any part of the Nigeria we may be for. But now, programming language has their own, computer has its own programming language that is used for a specific task. Now, when you come to hardware communications, so you need to understand C++. Assembly was the first programming language used back in the 60s. And remember, no matter any language that we are writing, it's still converted to 1 and 0, which is assembly. And we talk about the fastest language we talk so far that was the assembly language. All the language that we are writing, when it's being turned back to 1 and 0 and is assembly for computers to be able to understand. But these languages are complex to be able to understand. That's why we now see that is development to be able to, for developers like us, begin to write different patterns in making this programming language more easier for learners, for individuals to be able to mastermind and to be able to carry out tasks as quick as possible. Now, for every hardware, you can use your Rust, you can use your Java, you can use your Pythons. So now, when you are writing Python for hardware, underneath it is still converted to your C++. And we always talk that C++ and C, they are the modern language. So we have this is a module. When I was talking about module in my slide before, this is a camera module interface with a microprocessor. That is what you have in your drone. When you see Mr. Femi carrying his drone, and this is the principle that makes him to be able to press a button. Now, when he press a button to control the drone to move left and right, it's using the microprocessor is communicating with what they call port communications. And port communication is interfaced with 1K resistors for that button. Now, when you are designing that, what they call rebounds. Whenever you press that thing, the computer understands that there is always what they call rebouncing. to communicate with the port. And now, if the port now send a signal to this camera, capture this particular crop, capture this particular image. Now, once you capture that image, the computer did not see it as a maize, it didn't see it as a soya bean, it didn't see it as a what? As the cassava. Now, the image is captured and the computer interprets it into a signal. So now, as an engineer, if I will come into the field and I want to program the cameras, I'll be telling an engineer to tell me the signals. So you that you are not an engineer, you may not understand. I won't ask you to send me images. I will tell you, let me know the signal, because it's the signal that I will do what they call signal splitting. It's the signal splitting that will split into lines. Line that will now be what we program and interpret back into what? Into images for you to see that, okay, we have 10 images of what? Of maize. These rows on this line, we have 100 maize on row 1. In row 2, we have 50 maize. In row 3, block 1, we have maize. Now, when you are looking at disease, all those things, but computer did not see it as a disease. Computer is seeing it as a signal. And that way, when you come to engineering, electronics, or mechanical, we do what they call signal communication principle. Signal communication principle. This is another module. Now, this is a module. The red module is what they call GSM module. That is major aspect of your phone that you are holding. The place where you slot in your SIM is where the module is. And now the module is once you interface this red module with a screen and other components, you can be able to perform instruction. Okay, images, see my camera, communicate. When you send a number, and the number sends to another phone. Now, using satellite communication, now this is the module that make it to be possible, and that is what's inside your phone. Now, the same thing can now be used to design any actions. For example, I want to activate a satellite from here. That okay, once I'm in Lagos, I want to activate Mr. Femi cameras, drone to pick up and start working. So I could do that with all different communication principles, and one of them is the GSM communication, and through the use of modules. So back early end of our lecture, I talk about schematic design. These are schematic design of what you see in every engineering devices. In every devices that you see, there must be a schematic design, and this is the example of it. And the other side is your PCB board, which you already see on your devices, either a green board, a red board. Is called printed circuit board. Thank you very much. Before that time, before we wrap, we open for different questions. Let me show us one of our latest work that we're doing with Qualcomm in US, and this is our new board. This is a new board. I don't know if the presenter can just zoom. We can just zoom this for us to be able to see. Now, what we're doing here is that we're bringing edge computing to farmers. We don't want them to capture data. We discover we want to increase the level of precision in digital agriculture. That okay, bring the device closer to the farmer, to where you are capturing the data. That is where edge computing comes into place. Because when you capture a data from a long distance and you send it to the cloud, there is a level of signal loss. There's a level of now it gets to say that we want to measure high level accuracy in data capturing, and that is where this is our latest design that we are integrating into iOS, that we're using edge computing with other protocols to be able to bring a remote server closer to where we are capturing the data, and before sending it into the cloud and to use. And these are embedded system principles. Embedded system is just around you, is in your house, in everywhere. So having ground knowledge of this and in applying it to agriculture, we can use it to design a robotic system that can do weeding for you, control your tractors and other aspects of agriculture. And we are glad that with our hub, we've been doing that in digitalizing agriculture and giving Africa a better hope and bringing Africa on a map that is not only outside Africa, but Africans that are doing something great that can revolutionize the world of technology. And we are so glad that we are teaming up with young minds like Mr. Freddy to be able to make these things accessible and for Nigerians and for other youth, that we can combine knowledge to be able to design products that are enterprise driven, that can solve a particular problem in agricultural sectors, and that can easy food production, and at the end of the day, create jobs, create job for youth, and also change the perspective and the way Africa, Nigeria is seen to other Western world. And thank you very much for this time. And I'm open for any questions. And I hope that maybe we can have another session which is going to be purely practical. We are going to design one or two solutions that can be implemented in agriculture. And we hope the organizer can still give us one session to be able to have a full practical or a full applications of what we talked about so far. Thank you very much, and I'm open for any questions or any engagement. Thank you for your time. I really appreciate. And Mr. Femi also, we really appreciate you creating this platform to be able to unite us to bring out what we are doing at Maotronics into your community, and to be able to extend our knowledge bank and to see how collaboration can be possible. Thank you for what you are doing for African youth and Nigeria youth in particular. And I myself, and on behalf of my team, we really appreciate you, and we are open to be able to support and to see how we can add something to what you are doing, and to also to create our own quota in Africa, and to see how we can both grow together and revolutionize agricultural sector. Thank you very much. I really appreciate it. I'm open, Mr. Femi. You can take over, sir. I don't know. Can I start responding to the question? A good example question from Mr. Ahmed.
Yes, please. Yes, please.
Yes, Mr. Ahmed. Good to see your question. Good to see you using GSM module. I'm curious which feature you are using. SMS, voice. Yes. Thank you very much, Mr. Ahmed. Good to see your questions there. There are different features that we're using in the GSM module depending on the task that we're carrying out. We are successfully using SMS, whereby send a good example in one of our device, which is our major groundbreaking solution, the iWet. We're using not only SMS, we are using also HTTP protocol in the GSM module to be able to use the internet, to provide internet to the device, to communicate with the server, to be able to send the signal that the soil moisture, the relative humidity sensors is speaking from the feed into our remote server. So we are using HTTP in the GSM module. Also, the GPRS that we've used so far to capture locations of where all our feed is. and that features is used in the iWet also. Then we're using the SMS to be able to send message to the farmers, and also for the farmer to be able to send a particular logic number to be able to activate the iWet if they don't want the iWet to activate himself. So if the farmer just look at the temperature is high, they need to perform irrigation. So he can send a particular decode number by SMS to the iWet to be able to activate it. I think one of our solutions on this platform, which can still be changed, I think we are using 1 to on iWet, and we are using 0 as SMS to off the iWet. So although it can be changed for security and for security reason for that. So once you have the numbers, the GSM number to the devices, so you can send these numbers to communicate to iWet, and that's various way we've used GSM module, and we're still using a lot to communicate. Thank you very much.
All right. Thank you so much, Matthews. Really appreciate. Yeah, I mean, we've been having a very good engagement. People are actually, for example, we have Mini K actually saying your lecture is simple, clear, with relevant examples, and she's actually enjoying it. So that's actually a positive feedback and actually a delight for me and for us to actually learn, from you and the way you actually. I always trust your pragmatic way of actually sharing your knowledge. I wish. Yeah, good thing is that this lecture is recorded, so many other participants or registrants can also get on and also learn from your class. I can see Samuel, I can see Eberichi one call, okay. I can see LSD drone, I can see Ahmed, I can see Ibukun Lawa, I can see I think Kola is also yeah. We have some questions here, and I can see Shitu. Thank you so much for joining from Saudi Arabia. Thank you so much for that. So yeah, let me find some more questions. Okay, Ebe Richie is also asking this question. So thank you for your class. You really did justice to that. Sorry. My question is, as much as IoT is relevant, does it have any disadvantage on the long run?
Ebereshi, thank you very much for. There's no any solution, there's no any technical solution that does not have its own disadvantage. So one of the disadvantages that we're looking is that signal dropping, and that's where we're coming up with. Qualcomm. Qualcomm, they are the maker of smart dragons. So they make a lot of microprocessor for Samsung, for Apple. So we happen to be one of their selected startups in Africa that were representing them. And of subsequent time, we see how the Precision Field Academy with us can key into one of the benefits that we're bringing to Africa. There's a lot of disadvantage. And one of my major focus now is the cybersecurity aspect of it. Now, data can be hacked because it's traveling a long distance. Another problem is communications. Now, if there's always problem in signal in Africa, like last year, I'm working with a satellite provider in Barcelona, whereby now farmers, because what we're creating solution for farmers, and these farmers they are in the rural area. Now, it's not all the rural communities that have satellite communications. Now, what we're doing now with IoT is that we're bringing what they call terrestrial communications, whereby now we are not using GSM principle. So now we're keying into the Elon Musk satellite also. It's giving the startup in Barcelona access to their what they call NGP10, which is purely now we're creating a purely communication satellite for IoT because of this signal problem in tapping data. Because when you're talking about precision agriculture, the data must be real,
Yeah.
must be real and must be accurate in order to
Mm.
make right decisions. And in order to do that is to bring the data bus closer to where you are trapping the data. And in order to solve this disadvantage, that's where what we call edge computing is coming into place. Because putting the data and sending it into the cloud immediately, it won't do justice to accurate data capturing. So the best thing to do is to integrate edge computing in between the physical computer, which is the sensors, and to be able to pick that data and also store it before sending it into the cloud, so you can have accuracy. So there is a lot of disadvantage also. But nevertheless, sometimes we don't think about disadvantage more. We think about the advantage to the community and to the impact our community as an engineer or as an investor. Thank you very much.
Yeah, thank you so much for actually answering that question. Oftentimes, you know, when I also go to speak about, let's say, drone technology, and you just see somebody ask, like, oh, you have been saying about drone technology, that, like, and you have not told us the disadvantage. And I will laugh, I'm like, do you expect me to tell you the disadvantage? Well, anyway, but it's actually critical of us to actually think about what are the downfall or the pitfall of this technology. However, technology remains a technology, and there's room for improvement. I think the fact that it is not a perfect technology is a demerit, is a disadvantage in itself. So, for example, when they ask me that question, like, yeah, I've been saying a lot of things about drone technology in agriculture, but drones cannot, as of today, plow the land. So therefore, I need a tractor. So I'm not saying drones are yet to replace tractor in the real sense, you know. So, but it's to actually complement what we already have. So there's a way for us to actually improve on our technologies. Thank you so much, Iberici, for actually asking that critical question. I actually appreciate that. We have Ajibola. I don't think this is a question, but I would like to put it up. Application of embedded system technology in developing a tractor. Auto drive. What are the available options for making? I hope you get that question. Like, we can make sense of it.
Yeah, making it work. No, when it comes to
Okay.
tractor, now that we're talking about what they call megatronics. So
Hmm.
when you want to apply embedded system design into to perform tractor, because we're talking about hydraulics. So we want to control the
Okay.
level of hydraulics to move whether up and down, to pick up the
Hmm.
rigger. So a lot of electronic hydraulics is coming into place. Now, a good example of this hydraulic principle has been used in automobile. In some of the latest cars, they are using air absorber with sensors. Now, when it comes to tractors, because it's an heavy duty, now power, factor power is very, very important. Operational powers is very, very important. And that's one of the things that makes precision agriculture to be more expensive. And
Hmm.
applying it, carrying out in Africa is one of the major concerns. That's why when you see us as an embedded system designer into agriculture, we're creating the one that is affordable. So
Hmm. Hmm.
implementing it in tractors is more expensive. It's more expensive, but it's possible. It has been done, but it's a heavy kind of research or devices for tractors, and it's used
Okay.
in Europe because the European government are supporting their incubation center to be able to carry out this heavy research. But
Okay.
for tractor, it's perfect. There are a lot of things that Nigerians have done. But what happens is, every investor or every investor is also
Uh, can you? Um, we cannot hear you anymore, Matthew. Are you still there, Matthew?
encourage we can communicate. So that's just it. As I've said, that we look at a better system design that is the thing that we have to design something that is affordable for the smallholder farmer to be able to absorb and use for food productions. So if government and private sectors can invest so much for developing solution for tractors, they're already available. But we're also looking at what can be easily accessible to commercialize, and that's where we're focusing on developing some micro services that the smallholder farmer can start using those technology. And that's where you see the drone that is used today. And if you still look at the drone, it's not all smallholder farmer that can what that can accommodate it. So that's where also impact investors that are coming on board so to be able to have stand in between us and them, because this technology is really meant for them. But also we have to look at affordability, and so that's it, sir. Thank you very much.
All right. I think we are having tons of questions rolling in, and I think you're actually ready to actually give response to them. So it's a testament that people are actually relating to your lecture. So I would put up this. Okay. So we have second question from Ahmed. He's asking, in using any of these features, there is a need to renew subscription, either prepaid or postpaid. How do you manage subscription renewal? And after delivering the solution to the farmer, who are responsible for the fee? I guess you already addressed that, but just give one or two sentences so that before we move to the next question.
So, one of the things that we're doing is that we are providing two-way business model. So either it's coming as a service, whereby now they pay subscription to it, whether monthly. So also in the solution, there's also auto renewal or deactivate instruction that the system can deactivate who is not subscribing. And also we have another way to whereby the farmer or the user has total access to it. A good example is one of the one that was deployed in Sotri farm. They totally absorbed it, but there was an impact investors for that project. So there was an impact investor that pay for all the whole thing. And like for example in Ukraine, there was already impact investors also, which a organization has already paid for them to be able to deploy and own it. So either they own it or they subscribe. But in doing subscription renewal, you as the investors, you've already put this thing, because these are one of your bottlenecks that you have to consider in architecturing this design. So if these people didn't pay for it, what happened? So your system should be able to auto disengage them until they pay for it. But we definitely know that every technology always has a pain of the neck, and that's what makes us to be innovative. So is that pain that will create a solution, another solutions. Thank you very much.
Okay, so the next question is, says most farm settlements are in remote area, that means in rural areas or location. How do you manage a situation where network reception is low or does not exist in that area?
We've already attend to that earlier. That's where we're talking about MP10 satellite communication and terrestrial satellite communications. And that's also use of edge computing come into place. So whereby those data can store and pull out later.
Okay, so the next question from caller is, how can embedded system help and assist yield prediction? Great lectures. Also, to learn more about IoT, how do we connect with you? Let me, before you actually answer that question, so please be sure that this is what we are actually looking at doing, to connect you with leaders and practitioners, and so that you yourself can become another Matthew Ajibola, making products that African farmers can be able to use, or farmers in your locality, wherever you are, you can be able to use. So we are hoping to actually have more of a practical section with Matthew Ajibola sometime very soon, which will be announced. So it's going to be hands-on beyond just this virtual lecture. You can be able to do one or two, products learn hands-on, particularly. But yeah, the question is how can we actually use this in lead prediction? Ajibola, over to you.
I think connecting with us is you've already connected. Once you have Precision Field Academy, so accessing to us or having our contact is as easy as anything. So it's already is a family and it's a community that we're going. So being under this community, as long as you have the team lead of the organization, so having access to us is not it's not a problem. So you already have a passcode, a password for him to be able to access to us. So once you relate with him, we have his contact, and I believe you do. Then accessing to Maotronics and to our facilities and every other thing that we may want to do later in life, Precision Field Academy is there, and that's where we all be. Thank you very much.
All right, so it's actually asking about how can embedded system enable yield prediction? Yield prediction. Like you showed
Yeah,
some yeah.
we show some example. So we've done a research, a lot of in these predictions. I remember 4 years ago we were doing, even though how you use the embedded system to do breeding, Now we're doing what they call phenotypic selections of cassava. That's use of your camera phones, whereby you segment cassava flowering, the male and the female. So we can use it to do yield predictions as long as we're doing what they call penetrated testing. So now let me relate it to things that are common in our environment. If you want to do your yield predictions, use in embedded system for precision agriculture. Imagine when you want to dig your borehole, you call, you do survey, right? Now that principle is what is implemented in that devices that I send. Is all about the signals. So now the signal is now tailored into root and tuber. We're doing a lower range. So it's not doing there's a limit range signal penetration testing that the signal is doing down the root zone to be able to mention and predict and do selections. It can't the numbers, we count the pattern, it's patterns. Then the pattern now is scripted into algorithm to now say, okay, if you see 10 pattern, that is what? 10 yield, 10 number of tuber. Then look at the weight. That now it's not the weight that we're looking at the cross-sectional area of those tubers and the length. And then the length now is scripted to do, okay, if the length is 10 meter with cross-sectional area of 3 meter, then you look at object that is cylindric in human nature, and then to be able to say, okay, this object that is 10 meters in this radio, the weight is 1 kg. Then with that, you can now be able to develop your algorithms. Thank you very much.
All right. Okay, so another question from Ahmed is how do you achieve your PCB production? Okay.
Yeah, PCB productions actually, like we have the mini machines in Nigeria, and there's other companies that we've worked with, we have associate partner with. So there are different ways you can produce your PCB. Is that you produce two chemicals. Back then, our chemistry class, oxidations and reductions, is what happens because this board, your board that you are looking, is copper board. So now when you mix it with an acid, it will etch. So the local way of producing it, we can also show it in Field Academy when we have hand-on experiments that you can produce it back to if you are a chemistry student. So another one is what is called CNC production, where you use machines. So the machines move in different directions, and that's what is used to produce this. So the NC machine, we have a couple of them in Nigeria also. Then some company that we work with in Nigeria, so it's available locally. Then if we are doing mass productions, then there's some design we send to China because of cost, so that it can be able to ease in the cost of production. Thank you very much.
Okay, so is there any specific platform you can recommend to learn apply and apply the principles of embedded systems? If you want to actually, I think that question is very, very vital. If you want to actually give an upcoming embedded systems designer or architect, so what platforms do you advise them, or what process do you advise them to begin to learn, to begin to build their capacity in embedded systems?
And thank you very much. You know, one of the things I always say to anyone that the modern teachers that we have now is the internet. There's nobody can, don't let me myself or either Mr. Femi, I can't make me myself a god to you. Internet has been a platform whereby you can learn anything. As long as you can think it, you can just Google it. Then, now, what happens now is that the question is that how do you easy your journey into embedded system design or into precision agriculture? Is now when you now have expertise like us. So those things that you read, because when you want to do internet, before you find it, you do a lot of research, a lot of different reading from YouTube and this. And these are the pains that we went through to be able to learn on our own, the internet. Now, once you now have expertise, now they can shorten your journey. So that's why whether you come into Precision Academy, where you can have access to this, shorten your journey in learning this skill. So, but the internet has been the best platform, either from your YouTube to different post page to learn. But the time is what is concerned. So whereby we are creating a hub. Also, we are also creating a hub in Ibadan and other states, and also in UNAP also, whereby learning can be easier. So these are things that you get through Precision Academy. So we're already building it up, both in at least in 2 states now. We just secured one yesterday, which I've discussed with Mr. Femi with UNAM. So whereby learning of all these hands-on practical experience and applications of it, because there's difference between you learning it and apply it and turn it to an enterprise. Because we are more concerned about enterprise, we are picking research from the shelf into turning it into enterprise. So enterprising, learning things in enterprising way is very, very key, because that will give you Z, because we have short limit to start turning it to revenue for yourself, and that's what we get through Precision Field Academy, and you can get those link and expertise, and we're also going to be available in Precision Field Academy to be able to give this support. Thank you very much.
Yeah, good. I think we are actually getting to the question for now. Second question from the is, how can we know the particular capacity or model of the components we can use to build our own embedded system to solve particular problems? Yeah, if you can quickly answer that before I move to the next.
Yes. The question, nice question. But this is it. There is something that I don't need to create from scratch, because that's the beauty of technology. You don't need to do the science of it. You just need to do the technology, reverse engineer or modify the engineering. So you don't need to when you talk about model, it's a complex phrase. That's why I have to when you talk about model now in engineering, like you want to model your own component. So it will not be right for me to tell you to go and model this signal sensor. This is for current. So you can just get those components, get those models, and now use it to structure your principal model. You get the component, and which is available. We have online platform where we sell different electronic components, different sensors, and these are things that we also get through Field Academy, because these are things that we are giving access to Field Academy, Precision Field Academy, to be able to give everybody access to. Thank you very much.
Okay, so the next question from Ibukun Lawa is, for someone who is passionate about cybersecurity, where is the bridge in agriculture and embedded systems? Like, he's passionate about cybersecurity, so he's trying to explore between agriculture and embedded systems?
Okay, thank you very much. When you talk about cyber security, wow, I'm an ethical hacker. You understand? So I'm a cyber security certified, and I'm currently one of the selected in federal government project on cyber security. Now, bringing it in agriculture now. Yes. Now there are a lot of data that is being moved through digital platform as related to agriculture. Now, don't think now when it comes to this high level of data signal capturing, is not for the smaller farmers. There are different international institutes that are moving, which have worked with, that are very, very particular because they are high level agricultural research that is going on in Africa. Now, data capturing and data encryption is very, very important because there are some research that they don't. There are some research that they don't want to be out there. Now, cybersecurity, where cybersecurity comes in, is bridging the communication from the field, whereby the data is trapped into the cloud.
Actually, it seems we lost you. Um, so while we actually wait for Matthew to be back, yeah, thank you so much.
Now,
Even
how do you
okay,
so
okay.
now that is so encrypting your port from your hardware design is where your cyber expertise start coming into place because you are going to be using IP to communicate with your processors. So in understanding encrypting, disencrypting, and what you call modulation communications is very, very important.
All right, all right. So we also have a question from caller. I'm not sure. Said I'm interested in configuration of tractors for auto driving. What are the areas I need to concentrate on in embedded system and the programming language to use?
Yeah. Thank you. We've talked about when you want to communicate, when you want to focus on tractors, so you have to be grounded in megatronics.
Hmm.
So megatronics is more important. Now, programming language that you want to use, depending now on your functionality that you want to carry it out. But the first one that you must understand is the C++, C and C++, which is the core art. Then now, if you want to be communicating, you want to be controlling it, the kind of the joysticks that you want to be using to control your tractors, is it on the remote server? So now you are going to be learning front-end, back-end, server services, web services to be able to communicate. So you are going to be so from C++ to now creating application software, which either you are using Java, you are using Ribbon, you are using Python. But for you to start from the ground, you need to understand C and C++ as related to embedded system design to be able to control those hydraulics that you want to move. Thank you very much.
Okay, so there's another question very similar to that. Just actually give a few sentence answer on this. Is it necessary or mandatory to learn all or some of the programming languages needed to build our own embedded systems? Please, we need platforms on where we can learn. I guess where they can learn about these languages.
Yeah. Nowadays, now you don't even need to learn languages. There's a lot of platform, a lot of drag and drops that is coming to play for you not to learn languages. But you must understand now when it comes to you are moving from academics to design enterprise, you must understand language. A good example, your Arduino. Your Arduino will introduce it to it whereby you can do a kind of the program has been 50% simplified for you. But now when it comes to you designing a solution that you want to sell out, you must understand programming language. And the basic is first of all for embedded system is C++. Because you want to create a product of your own. So it's now
Mhm.
going. There is a transition from academic to an enterprise because you cannot license what you don't own. You can't
Ah,
patent what you
okay.
don't own. So you must.
Mm.
So that's those you must understand those language to be able to write or customize algorithms for those
Yeah.
processors to be able to perform tasks that you want them to be. Thank you.
Yeah. All right. Thank you so much, Martins Ajibola. I mean, guys, something that always inspires me when I actually listen to Martins. We've actually known each other since we now days in 2014, 2015. You know, so Martins has actually been doing all of this stuff since the days of his horticulture. He mentioned that he studied horticulture at the Federal University of Agriculture, Abeokuta. And I mean, his project was also on embedded system while he was studying horticulture. And I still have that. I think you showed a picture of that cubicle where for micro growing
Yeah,
of
yeah,
tomato.
yeah,
Yeah. I
yeah.
mean, it's actually very inspiring. He is an example of person I can say is a player, you know, when it comes to not just being an observer, like, oh, this is what is going on now, oh, this is driverless tractor or something like that. He is developing solutions for Africa, you know, for its immediate agricultural challenge mitigation, you know, solutions, different solutions. And it's always inspiring to know that. And by the way, you should know that the person speaking to us today, that's Matthew, he has a lot of patents to his name. So if you want to have patents to your name, I think this should inspire you to actually dig in, to actually learn for yourself. It's very, very important to actually give time to learn, to actually build your interest and passion, in what you are actually, what you envisage. Our goal is to actually raise more people who are not just observers, like I said, but to be players, to be people who are inventors, who are creators. We have people in Precision Field Academy already who are now developing sensors, soil sensors, that is actually connected with IoT onto their mobile and all that already. And we want to actually have more of that. So yeah, Eminike, you said you want part two. Trust me, we are actually having that cooking up, and it's going to be better than this, like we said. So we're going to be working with Matthews to actually bring the solution closer and to also help you grow your passion or perhaps keep the fire burning in you. It's very, very important. As a matter of fact, if it is just only just few people that we have that we can say, yeah, through this incubation program, we are able to have incubated people, to become players, to become inventors, to become innovators, to become entrepreneurs in this space. I think that is more than enough. I think that is more than enough. But we have to have hundreds of people, by the way. We want to have more people, and that's why we are investing our time and energy in this. Yeah, all for free. Why are we doing this? You already said it. Thank you so much, Matthews. I see a comment from Shitu. Said this is a great time to be proud of our home. Yes, we are proud of you, Matthews, and the future is exciting. That is what I know. The future is exciting, propitious, and full of bliss. So thank you so much, everyone, for joining. So Matthew, before we actually wrap up, because we don't have questions anymore, before we wrap up, I want you to actually give your final words, be it encouraging, be it instructional. Yeah, the floor is yours.
Yeah, thank you very, very much. I really appreciate. I will start from using Mr. Femi as an example because gold is not just made gold. You understand? And silver is not made silver. Either is diamond, just become a diamond. Mr. Femi have sold cucumber, a first class student, on campus. You understand? My brother and my sister that you may be listening to me have been a conductor on the street of Lagos. I've drove down for and do conductor from Oshodi to Yanapaja, from Yanapaja to my two. You get? But today I own properties. Today I own property. Today I have staff working for me. Today I've never applied to any job. I've worked for international organizations. Mr. Femi is an example also today, but we've had one dream. We want to own it, we want to own our own. So having a dream and be focused, and it can take so many years. Yesterday, when I was in UNAMS, tears run down my eyes when we went to the site located for us. You know why? And all the institutes said that it took you 10 years and you are still pursuing these dreams when something was not even having a light. But now when somebody will now come to tell you that, oh, a whole of VC of a whole institute coming to call you and walk up with you and say, this is what we want, and if it's not okay with you, we are ready to do what you want. The journey is not the testimony. I said to someone, success is sweet. Success make us smile. But the price and pain to pay for success is not an easy thing. Now, when you show your path, wherever the path that you might have taken, but be glad to pay the price. But if you are not clear of your visions, you can follow my vision. But remember that if you follow my vision, you are just helping me to achieve my visions. But I'm paying the price for you to be able to follow my visions. So what I would tell anyone on this platform is that have your clear visions and be ready to focus with it. There's going to be a tough time, but the tough time don't last. The tough time don't last. I'm ready to pay the price and be loyal to the people on your way to the top. Be loyal, be faithful, be consistent in anything you want to do. Even if those things, they are not really making sense to you. But along this journey, always validate your idea if it's real. Validate it if it's real and seek for mentorship. And it's not everybody's advice that you can take. You get it? So it's not everybody's advice you can take. But there are some God-given, God-sent people that will come your way. But when they come, key into it. Make yourself ready for any opportunity. I will wrap up this opportunity, this my communication with you. When I was going for my service, I was in final year. I knew that I'm not going to work for anyone. So I've tailored my final year project to be the asset that will catapult me to unlimited opportunity. So now, during my service year, I say requested for me, and we're trying to do it. I was not able to get access to the DG of IIC. We did a lot of things. There is always human factor that will stand along our way. Now, after a date to my signing out of IIC was at the D-Day, that preparation meet opportunity. We were 100 core members passing out of IIC. And I remember Sanginga asked every single of core member passing out, what do you want for me to do for you? Out of 900 core members, about 95 have spoken. I was to be number 6. Everybody asked for scholarship, for work, to go and do their master or give them a job. But I was the single core member that asked for, I don't want to work. I want you to invest in what I've done. I've developed 5 products for this institute during my service year. I want you to invest in my company. And this is my company, Maotronics Systems. And the man looked at me and said, what have I done? And I told him, we've developed this project. IIK has been doing irrigation for over 50 years, but they are not doing smart irrigation. This is what we've done. This is what I've done. This is what I've done. And the DG, you know what the DG said to me? And he immediately replied, all the 95 core members, I said, I cannot give all of you job, and I cannot give all of you scholarship. But do you know what can give you scholarship and job? This is what this young man has developed. I'm going to invest into what he has done because it can create jobs for over 100,000 of youth in Africa. And that was the genesis of where I got my first grant. And that was the genesis of what has given us grant today. And that was the genesis of what has spread us. So in In summary, please, brother and sister, prepare yourself for opportunity and always
Mhm.
learn updated skills. Thank you very much.
Hmm. Thank you so much, Matthews. Thank you so much. I want to actually say this to corroborate what you said about positioning. Uh, you see, we build skills, okay? We build skills for us to be valuable because if you are not valuable, people will not exchange value with you. It is the skill that you build that you want to actually exchange as value to your world. But when Matthew mentioned about positioning, and I also realized that you don't build opportunities, you only optimize for opportunities. And optimizing for opportunities means that you are actually strategically positioning yourself. And positioning yourself also might also mean you actually having the skill that is needed per time. And they said that an opportunity meets how do you put it the other time when the GT actually met you? It was just super coincident, like, but you are actually prepared, you are actually positioned. And when he actually posed the question, you actually fired him. You got him straight on. So yeah.
now, sorry to add something to what you say. Do you know that after 2 years of my service, I brought NYCDG to IIC. NYCDG was came to
Oh yeah, yeah.
Ibadan from
I saw it.
Abuja. You remember?
Hmm.
Yes, and
Yeah.
I was painted as NYC core member that is still making impact during service and after service after
Service.
3 years.
Hmm.
So when we are talking about learning, please, we must continue to learn, updating ourselves, as Mr. Femi
Hmm.
said, because it is
Yeah.
what will keep us opportunity. I'm also still learning. I'm learning
Yeah.
and I'm surrounding myself. You have to surround yourself with armies of men because it's not all the skill that you can have. Armies of men that will create opportunity. Like, okay, yesterday, I went to UNAM with one of my business associates, and unknown to me, a VC of UNAM has already have engagement with him, and we've been so as a business associate through an incubation that connected us together. He was one of my
Hmm.
facilitators. Now he now became my friend and already a brother and a business. So, but now technical expertise that we're surrounding ourselves because it's what will ladder us to the level that we want to get to and the right set of skills. And I really appreciate that we're having this kind of engagement. It's for us to, it's not to look at yourself, look down on yourself that you are not learning. Time is not too late. Now to burst your bubbles, because I said success is not, it's always smile, always good to recognize it. It took me over
Yeah.
10 years to finish my BSc. You know, I told you,
Hmm.
it took me over 10 years to finish my BSc because I have passion for something. But today, the 10 years was my learning processing
Hmm.
for my BSc that took me that year. Was now the 10 years, all the skill set that I've learned is what I'm using. Now, I didn't count it as a wasted year when I was moving from
Mm-hmm.
FUTA to another university to UNAM. So I was learning a lot, and but those periods was like a stagnation for me. But I was
Hmm.
soaking my skill set and all those things. But now it's creating opportunity, and we are growing. And I will let you to know that I'm accessible through Mr. Femi for us to have a good mentorship growth. So I want to see us expanding. I want to see how we can support your dream. We can energize your dream. We are nobody, but we can give our
Mm-hmm.
little quarter to be able to actualize your dream and your goal and objective. And we can also
Yeah.
able to be able to align you. We can work together. We're all good in our different areas, but when we come together, we become a force that cannot be what that cannot be overcome. So we can move mountains together, and that's just it. Thank you very much.
Thank you so much, Matthews. Thank you so much. We do appreciate your presence. One. Number two, we appreciate the value to which you bring, the passion, and how you're able to distill this complex knowledge of IoT and embedded systems, to us here at in this precision agriculture incubation program. So, guys, I hope you actually had a wonderful time. Thank you so much for joining today. Just to announce to you and remind you, we have another amazing section happening tomorrow, and we're going to be having Corey from Kenya. Is actually a geospatial data scientist who actually leverages on satellite imagery in agriculture. He calls himself the satellite farmer. So, and is also working with Amini. Amini is actually an agriculture industry focused insurance provider. So you'll be learning how satellite imageries, remote sensing particularly, if you want to capture it, is applied into agriculture, for agricultural solution, for policy making, for into farming and into supply chain and various. You would be learning that. And trust me, practicality is the cruise of this program. I want you to take it from me. Okay, practicality is the cruise of this program. So we are going to be infusing practical sections, be it from experience or hands-on, be it virtual or even physical class that we are going to still be having. So be sure about that and don't miss it. Tell your friends, share the registration with them, share the link with them, let them actually be part of this program. Our joy is to actually reach more people, to be inspired. One person being inspired, sparkling another person's fire, another person sparking more people's fire, that we can actually change the narrative. We can actually raise more tech inclined and, becoming tech oriented farmers or agricultural professionals together. So thank you so much once again, everyone, for joining. It's actually very amazing. So tomorrow is going to be by 2 p.m. Nigerian time, or GMT plus 1 Nigerian time. So 2 p.m. we're going to be having Koreko from Nairobi, Kenya, to take us on application of geospatial technology, particularly satellite imagery in agriculture. Thank you so much for joining once again. So at this point, we say bye. See you tomorrow.
Bye.